All right, so this lesson, we're going to be doing some trig graph applications, but we're also still going to do just a graph or two. So on this first one we're going to do is actually all of these problems we're doing are problems out of the book. So this is number 56, and the directions just say to sketch 2 full periods. So 56 is y equals 2 cosine of x minus 3. Now, this is the first one we're actually graphing that has a vertical shift. All right, but we're going to start off the exact same way by finding the amplitude, the period. Now, as far as phase shifts go, this one doesn't have one because there's no addition or subtraction inside the parentheses. But this one does have a vertical shift, and that shift is down 3. Now, it's nice because we're going to start at 0, and then that would mean we're going to end at 2 pi. All right, so let me go ahead and draw the x-axis. All right, now this one is shifted down 3, so it's going to be a little different. 0 is the starting point, so that should be in the middle, which is where the y-axis is. Now I'm going down pretty low on the y-axis. So I'm just going to, I know it's down 3, so I'm going to go 1, 2, 3. And then that is where I'm going to draw just like a little dashed line, like kind of as a guide. So that's going to be the baseline of my graph. Okay. Now, the end of my period, it starts at 0. It's going to end at 2 pi. All right. And then halfway between that is pi. And we have our pi over 2. And then 3 pi over 2 is our other halfways. All right. Now, so this one's going to be sorry about that. There's a super long announcement. So anyway, hopefully you fast forwarded. So we are going to graph cosine from our baseline of -3. So the amplitude is 2. That doesn't mean we go up to 2 on the y-axis. That means from -3, we're going to go up 2 units, and that's our maximum. All right. And then instead of an x-intercept where we normally have it, we'll have a point at the baseline, a point at -3, right? And then our minimum is going to be down 2 units from -3, and then back to -3, and then back to a maximum, right? So it's kind of weird, a little different than what we're used to. All right, so that's one period. And when we do a second period, when our starting point is 0, it's kind of awesome because we just do the negative versions of those numbers on the right. Right, and then we'll start up at our maximum, which is at -1, and then our baseline, and then our minimum, and then our baseline, and then we connect them. Okay, so that's how you do a graph with a vertical shift. Okay, so the next one we're going to do is in the book, we're going to do 73. All right, so the directions say to find A and D for the function such that the graph of f matches the figure. So A is going to have to do with the amplitude, and D is going to have to do with the vertical shift. So what I do is I look and try to see like where the middle or the baseline of the graph is. So to me, it looks like that is the baseline. And so the original graph is shifted up 1. And then to get the amplitude, I'm just going to count from the baseline to the maximum is 1, 2 units. Or from the baseline to the minimum, same thing, 1, 2 units. So that would make our amplitude 2 and our vertical shift 1. Okay, and then 88 is the last one we're going to do together. And it says for a person at rest, the velocity v in liters per second of airflow during a respiratory cycle from, the respiratory cycle is the time from the beginning of one breath to the beginning of the next is given by that function where t is time in seconds. So we want to find the time of one full respiratory cycle, and it's asking for a cycle, is asking for a period. And so to find the period, we're going to take 2 pi and divide it by the coefficient of, in this case, the coefficient of t, which is going to be pi over 3, or 2 pi times the reciprocal. So that's going to give us a period of 6. Now this has to do with an actual situation. So there is a unit for that, and that time is 6 seconds. So from when you start breathing in to when you finish breathing out, on that is going to be a 6-second period. All right, and then for B, it asks to find the number of cycles in a minute. So if one breath is 6 seconds, you can do 10 breaths in 60 seconds. So that would be 10 cycles per minute. And then finally, C, we're going to sketch the graph of the velocity function, and we'll just do one period. Now this one's nice. There's no shifts in this function. All right, so the period is 6 seconds, so we're going to go from 0 to 6 seconds. Halfway between that's 3 seconds. And halfway here is 1.5, and then 4.5. All right, if we're looking at our function, the amplitude is 0.85. I said that wrong. No, I didn't. Okay. All right, and then this is a sine function, right? Yes, so we're going to start at 0. We breathe in, our lungs fill, and then we breathe out, and they empty, and then we're back to normal. So a positive velocity is air going in, the speed that air is going in, Negative velocity is the speed that air is going out. Okay. So what I want you guys to do on page 307 to 308 is number 74, 90, 91, 93, and then also a worksheet that I am attaching. So I don't know what I'm writing, sorry. So it's graph trig functions worksheet.